Many centuries ago in ancient Greece, a mathematician named Pythagoras demonstrated an interesting truth about triangles. He demonstrated that if a triangle is a right-angled triangle and you make a square on each of the three sides, the largest square has the exact area as the other two squares put together. The longest side of the right-angled triangle is the hypotenuse. So the formal definition of Pythagoras' theorem is, in any right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So in a triangle whose hypotenuse is C, the square of A plus the square of B is equal to the square of C. Let us see if this really works using an example. A right-angled triangle has sides 3 centimeters, 4 centimeters, and 5 centimeters. Let's check if the areas bear out the truth of the theorem. 5 squared equals 25, and 3 squared plus 4 squared equals 9 plus 16, which is also equal to 25. This proves that Pythagoras' theorem is true. But suppose we don't know what the length of the hypotenuse is. If the other two sides have lengths 5 and 12, we know we can square them and add them to get the hypotenuse squared. So, 5 squared plus 12 squared equals c squared. C squared equals 169. To find the value of c, which is the hypotenuse, we have to find the square root of 169, which is 13. We can use Pythagoras' theorem to derive the formula for the length of a straight line on a graph. Once we have this straight line, we can complete the right-angled triangle by drawing in the rise and the run. The rise and the run would be the two short sides. So we can square them, and that would give us the length of the line squared. Of course, the length of the line would be found by finally finding the square root. So length squared equals rise squared plus run squared. Since the rise and the run are the difference or changes in the y and x values, respectively, length squared equals y1 minus y2 squared plus x1 minus x2 squared. So of course, to find the actual length, we then find the square root. So, if the line AB has coordinates 2, 2 and 6, 5 respectively, what would be its length? First, we assign values. x1 equals 2, x2 equals 6, y1 equals 2, and y2 equals 5. So the length of AB would be equal to the square root of 2 minus 5 squared plus 2 minus 6 squared. Which is equal to 5. Now remember, we're finding the length, so it must be measured in units. Can you find the length of the line PQ with coordinates -4, -6 and -10, -4 respectively? Be careful with the negative numbers. Let x1 be equal to -4, x2 equal -10, y1 equal -6, and y2 equal -4. So the length of PQ equals the square root of -6 minus -4 squared plus -4 minus -10 squared. which is 6.32 units. We can also locate that point which is halfway on the line. This point is the midpoint of the line. It is a point, so it has coordinates, and it is usually denoted by the capital letter M. The midpoint refers to the middle of the line. To find that point that is halfway along the line is to find the average of the two end points. Let us find the midpoint of the line AB with coordinates 2, 2 and 6, 5 respectively. We average the x coordinates and we average the y coordinates. Remember that the midpoint is a point itself, so it has coordinates, and so x must come before y. Averaging the x coordinates gives us 4 and the y coordinates gives us 3.5. So the midpoint of the line AB is 4, 3.5. So then, what would be the coordinates of the midpoint of PQ with coordinates -4, -6 and -10, -4 respectively? The midpoint would be -7, -5. So now we know how to find the length of a line as well as its midpoint.